All right, our next topic on circles in the coordinate plane is solving simple intersections, and that's the intersections of a circle and a line. So there's a couple options that we have. They could never touch. They could touch at one point. Okay, remember this is called a point of tangency. Tangency. Okay. That's a tangent line, or it can cross twice. And remember, this is a secant line. So a line that crosses through our circle, not necessarily at the origin or the center. So three types of intersections that we could have. Never, one, or two. We can solve it graphically. Okay, so we can graph the circle, which we've learned in previous lessons, and we can graph a line that we learned how to graph in Algebra 1, and we can tell if those points of intersection are an ordered pair. Okay. Not as exact as algebraically, but it could work. So here, for example, we could graph this circle. Okay, we know we can graph this circle because it's going to have a center at 0, 0, and a radius of 2. That's our standard form equation of a circle. We remember that we can't graph linear functions unless they are in slope-intercept form. And if you'll notice, it doesn't quite touch. Okay? So again, that's a judgment call. It's very subjective. Some of you might say it touches at 2, -1. Okay? So graphing is possible. It's just not always exact. Another graphing example. Okay? Again, we can graph this standard equation of a circle. We know that center is going to be at 0, 0, and our radius is at 3. So if that's the case, we can graph this circle. We cannot graph this line until it's in slope-intercept form. And when we graph them, it cuts through our circle twice, so we have 2 sets of intersections. Solving algebraically is, of course, going to take a little bit more work. We're going to solve the linear equation for one variable. Okay, so y. For example, since we already know how to put it in slope-intercept form. We'll substitute the linear into the circle. We'll solve for the variable, and we'll substitute back into our linear equation to find the other. So very similar to a systems of linear equations where we have 3 ways to solve. Here we have 2, graphing and substitution. So let's look how this looks. It's all typed up, but let me talk you through it. So x squared plus y squared equals 34. X minus y equals 2. Well, here we isolated it for one variable. Okay. We isolated one variable. Now, we chose x because it has a positive 1. It's a little bit easier to solve for. So up here at the top, this is our substitution step. We substituted it in for the x of our circle. Now you'll notice that's something squared. So we are going to have to multiply it out. When we multiply it out, we get something that's quadratic. And if we're solving, we're going to solve by factoring. Dun, dun, dun. It's come back again to haunt you. There is a GCF. We can factor, and we have both of these y values. Now, both of those y values are valid answers. We have to substitute them back into our equation. So these two things aren't our final answer. We have to circle back and substitute into the linear equation to find ordered pairs. So we circle back, we substitute it, and remember x comes first in ordered pairs and then y values. Okay? So the fourth example works the exact same. Okay? We're trying to find the intersection of this circle and this line. So when we isolated for one variable, we solved for x again, because when we solve for x, it's a little bit easier than trying to divide by 3. We substituted here. We find that we have a quadratic. So we're going to solve by graphing. And in this case, we have one y value, which is fine. When we substitute it back in, we find that we only have 1 point of intersection. Okay, let's look at some examples of how to solve this algebraically. And in these examples, we're going to cross out part B. Those just aren't good examples. And I'm going to use a sheet of notebook paper for some space on how to work. Okay, so in this case, we already have a variable that's isolated. So I'm going to substitute in for the y value. So in number 1, I'm going to have x squared plus 3x minus 5 squared equals 25. So that's x squared plus 3x minus 5 times 3x minus 5 equals 25. I'm going to multiply quickly. So this is x squared plus 9x squared. That's negative 15 and negative 15 is a negative 30x plus 25 equals 25. So in this case, our 25s are going to cancel. And I'm going to get 10x squared minus 30x equals 0. Now, there are two terms. When there's two terms, we have to ask, is there a GCF? That's pretty much the only question we have. And there is. 10 can go into both of these, and x can. So this is going to be x minus 3 is equal to 0. So I'll split my factors. I have 10x equals 0 and x minus 3 equals 0. So I'm going to get x equals 0 and x equals 3. So my final answers over here are going to be 0 comma something and 3 comma something. I'm going to go back to this linear function and find these y values. So I have y equals 3x minus 5. So I'm going to do y equals 3 times 0 minus 5 and y equals 3 times 3 minus 5. So y equals a negative 5, y equals 9 minus 5, so y equals 4. So when x is 0, y is a negative 5. When x is a 3, y is a 4. So these are my 2 points of intersection. Let's work on another example. Number 2. So I need to put this equation into slope-intercept form, so I'm going to do that up here. So this is going to be y equals a negative 2x plus 15. So again, I'm going to substitute in for the y value. So number 2. So we're going to have x minus 2 squared plus y. We're going to substitute that y with a negative 2x plus 15. Still a minus 1 squared equals 25. So just this portion here Holy smokes. Can y'all hear that thunder and lightning coming over my house? Sorry, that just scared me. This is just the part that I substituted in right here that y equaled. Okay, so I'm going to clean some things up and begin. So this is x minus 2 squared plus a negative 2x plus 14 squared equals 25. Again, x minus 2 times x minus 2 plus a negative 2x plus 14 times a negative 2x plus 14 is equal to 25. So this is x squared minus 4x plus 4 plus negative times a negative is a positive 4x squared. That's a negative 28 and a negative 28, right? 2 times 14. Yep. So 28 plus 28 is going to be 56. And 14 times 14 is 196. Yep. So plus 196 equals 25. So let's continue to clean some things up. So this is going to be x squared. Take that back. Let's combine like terms. I don't know what I'm thinking here. X squared and 4x, that's 5x squared. Negative 4x, negative 56, that's negative 60x. 4 and 196, that's plus 200, is equal to 25. So 5x squared minus 60x plus 175 is equal to 0. And again, we have a quadratic function. We're going to look for a GCF. It's going to be 5. And let's see, 5 can go in here 3 times. 2 left over, so 35 equals 0. So we're looking to factor this inside portion. So this is going to be x, let's see, minus 7, x minus 5 equals 0. I know that negative 5 and negative 7 and negative 5 multiply to be that, add up to be negative 12. So we'll solve 5 equals 0, x minus 7 equals 0, x minus 5 equals 0. That can't happen, so that's out. So x equals 7 and x equals 5. Those are my two x values of my ordered pair. So this is going to be, one starts with a 7, one starts with a 5. So we'll go back to our linear equation of negative 2x plus 15. And we'll have y equals a negative 2 times 7 plus 15. Y equals a negative 2 times 5 plus 15. Squeeze it in. So negative 14 plus 15. Negative 10 plus 15. So y equals 1 and y equals 5. So when x is 7, y equals 1. And when x is 5, y equals 5. And those are our two ordered pairs. Those are our 2 points of intersection. Go ahead and pause this video and try that third example by yourself and check back in for the answer. Well, just kidding. This example is not factorable. We can get to this point and find that there is a GCF, but this isn't factorable. Every example I'll give you will have a factorable component, so you do not have to worry about example 3. Please continue to practice on page 23 in your packet. It is front and back. Please check the blog for the questions that I'd like for you to submit your answers to. Happy studying.